In this video, we're going to be taking a look at how to build and deploy a full stack AI application pretty quickly in just a few clicks. Now, this application is going to come out of the box with a chat, agents, and even RAG capabilities. And this will definitely speed up your development process. It comes with all the features that you would need to start building most AI-driven applications, especially the ones that are conversational. So let's take a look at exactly how this application works. So as you can see here, I am on the landing page of this application. It does have a few options here, the option to chat. It has agents, retrieval, and you can basically ask, start chatting with this right away. So for instance, I could say, tell me a story about pirates. Now, the interesting thing about this application is coming out of the box with streaming chat capabilities and has also the ability to do retrieval augmentation generation as well. So if I go into the retrieval piece here, you can see it does have, QA over and chat over documents, and you can basically, run your retrieval. You can upload your document as well as get responses back from that document that you've uploaded, whether it's in text format or any other format. Now, as you can see already from the screen, this is a template that is coming from Langchain in collaboration with Vercel and Next.js, and they've built this really awesome template that comes with all of these amazing features. So I'm going to be showing you how to deploy this. Now, but before we actually jump into how to deploy this, let's talk about the stack itself. All right, so let's talk about the stack right here. So this stack is an interesting one. And the way I see it, it does appear to be one of the best stacks that I have seen so far. And I'm going to break down exactly what each of these components are really all about. So first and foremost, the web framework is Next.js. So if you're familiar with Next.js, it really simplifies, the ability to build these full stack applications based on React and server-side rendering based on Next.js API, which makes it easy for you to drop both your functions as well as your front-end components right in the same project, and it speeds up the development of these applications. On the back end, which is quite interesting, we're using Vercel for hosting. So Vercel is essentially going to be hosting the application. And interestingly enough, a lot of AI companies have been using Vercel to host the application. So the likes of Jasper, Perplexity AI, Scale AI, all these companies are already using Next.js, so as well as Vercel for their applications. So this makes this an interesting stack when you're building AI applications as well. Now, the interesting thing about this, which I really like so much, is Supabase. Now, Supabase, if you're not aware of it, is essentially a Firebase alternative. But what they have done, which is pretty interesting, is that their database is based on PostgreSQL. And because it's based on PostgreSQL, this makes the stack much more amenable to what we're doing with AI, especially when it comes to retrieval augmented generation and when it comes to using Vectorstore specifically. And this is because PostgreSQL released an extension last year called pgvector, which allows you to store embeddings inside your PostgreSQL database. Now, why this is really cool is that you can have both your metadata, other forms of data, along with your embeddings in one database without having to split between two. Now, on the AI side, what we have is Langchain and OpenAI. So Langchain as the framework we're going to be using, OpenAI specifically the large language model, but you can use multiple large language models for this. And now this is something that I didn't really, pay too much attention to before until I started trying to build a full stack application. kind of moving away from backend type applications and doing some demos here and there and building everything from scratch. I was looking for a very simple and quick way to build applications, and I came across the fact that Vercel released an SDK called the Vercel AI SDK, which is specifically intended to help you bootstrap and quickly build AI applications using this SDK. Now, the SDK comes with a number of capabilities, which we're going to be diving into very, very shortly, but it really simplifies how you build applications. So let's really go and take a look at the Vercel SDK, AI SDK, to take a look at what's possible here. So as it says, it is serverless and edge ready, which means you can deploy your AI functions directly on the edge, which means that it is much faster. But the key thing about the Vercel AI SDK is really around streaming, because the key thing that they've really built is making it easy for you to stream the chunks of responses or the tokens that come back from an LLM response. It makes it very easy to stream those right into your application very, very quickly. So you saw that when I did the demo of the chat, asking that question and getting a streamed response back. Now, this is very essential when you're building any chat-based applications working with LLMs, because of the user experience factor. You don't want people sort of waiting for the LLM to completely go through all of the processing before it starts streaming back responses. With this approach, you can start streaming those responses immediately. Those tokens are being generated. And this is such a very, very key aspect of building any LLM-driven application. We've seen this with ChatGPT, with Bard, and any other AI application that is out there. And these are the things that make them easy to use. So this comes right out of the box with the Vercel AI SDK. And the other thing they've also done is to build several wrappers around the more popular AI providers, obviously with OpenAI, AWS Bedrock, Anthropic, Gohair, Google, Hugging Face, Langchain. They've built this amazing wrappers that make it so easy for you to just really jump in and start building these applications. The other interesting thing about the Vercel's SDK is that they have also introduced a playground, which allows you to test your prompt and test your applications, as well as compare the different outputs coming out from each LLM. So as you can see here, we have the Mistral LLM, which is basically an open source LLM. And you see that they are actually providing access to it and pricing for it as well. So if you sort of want to kind of get information about each of these LLMs and want to see their capabilities and functionality, you can get them directly from here, from the playground. So for instance, I could say, give me an understanding of large language models. Now, once you hit the send, you could see exactly how each one is working. So you see which one is the fastest, you see how it's streaming your responses back, and you can then compare each generation. So we can see this one from Mistral, we see this one from Llama, and then we see these from GPT 3.5 Turbo. And we can see how each of these models performs, and you can go ahead and essentially configure each model with specific settings as required. So this is pretty awesome as you sort of think about building your application using Vercel's SDK, that you can get access to this, and also the code to use all of it is available, which is pretty awesome. So you don't really need to learn so much here about this functionality. You can quickly get either a TypeScript or JavaScript version of it, as well as what type of function it is, whether it's an edge function or just a pure Node.js function. You can get full access to that directly by copying the code, and you can get the code for each one of them right here. All right, so essentially that's what the Vercel SDK is doing. In the template that we're exploring, the key thing we're really looking at is around the streaming capabilities. So that's what we're going to be using it for. But again, it's something that you can use in your applications as you move forward. Now, let's jump into the templates to get it deployed. So first and foremost, we need to go to Vercel, and we want to go to vercel.com/templates, where they have a bunch of templates out here. Now you can filter by AI templates, and this would show you all the different templates that have some kind of AI capability in them, including the Next.js AI chatbot, which is built purely on that SDK I just mentioned. I think if you just want a very simple starting point, this could be a good template. But the template we're looking at for today is the Langchain template. So it's called the Langchain Next.js starter template. So all I need to do is simply go into that template. And to get it started, all you really need to do is to go ahead and deploy. So as you can see here, the framework is Next.js. Database is Supabase, not necessarily the Vercel version is using Supabase, as I talked about earlier on. So what we have to do here is to hit deploy. Okay, so first and foremost, I need to connect my GitHub repo. So here, my GitHub repo is already connected. So the repository name is Langchain Starter. I'm going to say hello. And we're going to just simply create this. So I'm creating it as a private Git. Actually, I'm going to make it a public one because I want to share this with everyone. So you can also clone it if you prefer. I'm just going to go ahead and hit create. As you can see, it's created a repository for this. So essentially, all you really need to do is to get your OpenAI API key right in here. I'm going to be entering mine shortly. All right, so I hit the deploy button after I entered my OpenAI API key, and now the deployment is going to get started. Now, this is going to take a few seconds, so I'm just going to pause right now, and then we're going to come back to this once it's completed. All right, so our application is now deployed, and you can either go directly to the application if you want to see access to it, and it's right now it's deployed to Vercel, so we can actually start playing around with it. Hello there, and we can see that our application is ready to go. So that is how easy it is to get your application running. Now, if you want to run it locally, I'm just going to show you very, very quickly how to run this application locally. So let's continue to the dashboard. So the very first thing we're going to be doing here is we're going to clone our GitHub right now. We're going to clone this particular repository. So this is our Langchain starter hello, and we're just going to simply clone this for local use. Now to do that, we're just going to go ahead and use the GH repo on the CLI. So I'm just going to go into my terminal. So I'm just going to go ahead and clone it. I'm just going to use GH repo clone hello hola Ugo, and I'm just basically just going to clone that. All right, so we're cloning the repository, and now we can go ahead and cd into this newly created application, and let's open it up in. All right, so we have the application open in Visual Studio Code. And now the very first thing we want to do is to go to the .env.example, and we need to essentially change add our Open API key, so which I'm just going to. So I've added my Open API key as you saw inside the .env file. Now you can change this .env.example. You can change the name to .env.local. So that's the other thing we need to do is to change this to .local. And now our env file should be ready to go. Now, before we kind of get started, the first thing we want to do is that we want to run a yarn install. So make sure you have yarn in your system. So I'm just going to do a yarn install. So this is going to install all the dependencies. A lot of the dependencies are going to be more around obviously OpenAI, Langchain, Supabase, all of those things are going to be installed. So just go ahead and hit yarn install. And this is going to install all of these applications. All right, so now we have our yarn install completed. Now we can go ahead and run our application locally by doing yarn dev, and this should start our application on the local port available. So in my case, it is localhost 3001, and here we have our local version of the app running. So let's make sure it's all working as expected. Hey there. And are we streaming responses back? Yes, responses are coming back. So our application is ready to go. Now, the other piece we're going to be exploring is the retrieval piece. And this is usually the really big use case for most LLM applications. So here we're going to be exploring how to ingest as well as retrieve information. All right, so now to kind of set this up, because right now it's not going to work. If I try to do an upload, it's going to give me an error that a Supabase URL is required. So let's go ahead and set up Supabase. So go to Supabase and go ahead and set up your Supabase. And the very first thing we need from our Supabase is to get access to our environment. So first we want to take go to the API section, and we want to grab our URL, our project URL. And what we want to do is to take this URL and want to go into .env local. And when you go to your .env file, you're going to see the space for adding your Supabase private key as well as your Supabase URL. So I'm just going to go ahead and add my Supabase URL and then uncomment that. So I'm just going to uncomment this. And then we can also go ahead and grab our Supabase API key. So that I'm going to also add here under Supabase private key. And we're just going to add that here. Now, so I'm going to change this, by the way, and revoke this before I put out the video, but I'm just basically updating that. Now, you might see also that, if you were trying to use the agent for search, you can add your SER API key right here. And if you're going to be doing tracing, Langchain tracing using Langsmith, you can add, the variables as needed here as well. And if you're using other models and stuff like that, you can add their keys here, and you can add whatever other key information you need as well. All right, so let me go ahead and make other changes in Supabase. So now we have our Supabase API key ready to go, but our database is still empty. So we need to create a new table. Now, to set up Supabase, you can go to the Langchain website and see sort of the section on Supabase. I'm going to put the link in the description as well, and you can see how to set up Supabase. And the main thing we're going to be doing here is we're going to be using this create a table and search function in your database. Now, what this does is that using pgvector, it essentially enables pgvector, which is for our Vectorstore, and it creates a table which we're going to be using to store our information. So that information would include an ID for our document, the content, text that is coming from our document that we want to ingest, a metadata that is containing like key value pairs about our document, so page number, document title, all of that information, as well as our embedding vector as well. So remember what I said earlier on, the fact that you can do all of this inside a typical database makes it much easier for you to set all of this up. So basically this is what we're going to be doing here. So let's just copy this schema and go back into our Supabase and get it started. Now, to do that, one easy way is to go to the SQL editor. I already have this actually right here as well. It's the same query, and all I need to do is just simply run. All right, so our document is now created. So if we go back into our tables, our database, you could see that we now have a documents table, and this documents table should include an ID, and embedding content for storing our vectors inside PostgreSQL running on Supabase. All right, so our table doesn't have any data in it right now. So now let's go back into our application and see if we can populate this table. So if I go back to the application, so just want to show you what's actually powering this retrieval piece. So if you're familiar with Next.js, you would know that when we go in under the app section of Next.js, your actions are being controlled in your API folder. Now you will see a bunch of different folder items here, or different routes. So there's a chat route, which includes all the functionality and backend powering all the different chat tools. And there's the retrieval piece, which is in two forms. One is for ingesting, as you can see here, and the other one is for retrieving the information. So I'm going to be talking more about the backend here. The front end page and layout are all there. You can go in and take a look at it. But here, what we need is obviously our request and response from Next.js, from the Next server. We're importing Supabase because we're going to be using Supabase and accessing the Supabase Vectorstore, and we're bringing in the Supabase Vectorstore class from Langchain that allows us to essentially interact with Supabase pretty easily. And we're using OpenAI embeddings here, which is essentially going to embed our information and store it inside pgvector as embeddings. So this is a pretty straightforward thing to do. So this is your typical server setup inside Next.js. We're using Edge as our runtime, and we are essentially here we have a body, and we're extracting the text from the body. And if I go into the most important aspects of this, first we're starting by creating a client for Supabase. So this is where we are initializing Supabase. We're passing the Supabase URL along with the Supabase private key. We're initializing our splitter using the recursive character splitter from Langchain. If you're not familiar with these concepts, I'm going to put a link in the description for the Langchain documentation, which talks about the entire RAG process as well. So here's how we split documents. We pass text or a list of text, and they get split and get created as documents. Now, once those documents are created, we're now using Vectorstore class to create these embeddings and store them inside Supabase from the documents that were created from our splits. So we pass those documents in here. So our split documents, we pass them in here. We're passing in OpenAI embeddings function, which we're going to be using to do the embeddings. And we under here for the client, we're passing our Supabase client, and we're passing in the table name, which is documents, and match documents, which is what we're using to do the retrieval of these documents. All right, so that's pretty much it. And if we go back into our application, you would see exactly where we can trigger this. So this upload button is basically calling that function we just looked at right now. So it's taking all of this text. So this is basically taking a very long piece of text. It's going to go ahead and chunk them into documents, and those documents are going to be uploaded into Supabase. So all I need to do is just hit the upload button here. And once you hit that upload button, it's just going to go through that process. So you say it says uploaded right now. It's going to go through the process we just talked about. And if we go back into our Supabase table, a list of documents which have been chunked, and you can see their embeddings as well. So you see the content text right here. So this is basically all the chunks that were split using the splitter. We can see the metadata right here as well, and we can see the embeddings. So the embeddings basically are the numerical floats which your vector store uses to retrieve information. Now, because we have all of this now set up, we can now query this database the same way we would query any other vector store, whether it is Pinecone, DeepLake, or any other popular vector store that is out there. So if we go back into our application, what we can do now is to ask the question, what is a document? So now this is pulling that information directly from our vector store and streaming it directly to our application. And in those few steps, we have a RAG application built out. You can see that the response is there. It also shows us the source from which is pulling this information. So it's pulling it directly from our vector store and is showing us the sourcing as well. So for me, I stumbled upon this when I was trying to build an application, and I thought I should share with you guys because it really simplifies the process of building the application. In a few steps, I was able to get it up and running. So try out this template. I think it's pretty cool, has some really awesome capabilities. Also check out the Vercel AI SDK to learn more about how you can use that to build your applications. Yeah, I found this to be pretty cool. If you want me to do a deeper dive into Vercel SDK, please let me know in the comments below. But until next time, do have a great one.